You know when you see these massive machines, like a giant power plant turbine, ever wonder what holds it all together? It's easy to just see the huge structure, but some of the biggest engineering puzzles are actually hidden deep inside. Today, we're gonna look at one of those puzzles, and a really, really smart way to solve it. All right, so here's the plan. We'll start with what I'm calling the giant bolt problem. Then, we'll get into the super clever solution using induction heating. After that, we'll see how the engineers created two different tools for two different kinds of jobs. And finally, we'll look at how this whole approach is all about tailoring the engineering for exactly what you need. Okay, so picture this. You're deep inside a power plant, or maybe a massive factory. The core machinery, the really important stuff, it's all held together by these gigantic bolts and tie rods. And I'm not talking about the kind you find at the hardware store. No, these things are huge and they're mission critical. They have to be insanely tight to keep everything safe and running smoothly. So that brings up a pretty big question, right? How in the world do you loosen a bolt that's basically the size of your arm, especially when it's been tightened with just an incredible amount of force? I mean, just trying to muscle it open isn't just hard, it's often really dangerous and takes forever. And that, right there, is the giant bolt problem. You know, the old school ways of doing this, we're talking sledgehammers, we're talking crude heating torches, they're just not great. For one, they are super slow, and that means expensive downtime for this critical gear. They're also really inefficient, just a ton of manual labor. But the biggest issue? They can be downright unsafe for the people who have to work in these really tight, tough spots. And this is where things get really interesting. This problem led to an amazing solution, a purpose-built industrial tool called the Nakai Bolt Heater. And what it does is completely flip the script. It moves away from all that brute force and introduces a method that's way faster, much safer, and incredibly precise. The magic behind it is a technology called induction heating. Now, the way this works is actually pretty intuitive. You know how when you have a stubborn metal lid on a glass jar, what do? You run it under hot water, right? The metal heats up, it expands, and suddenly it's easy to twist off. Well, this is the exact same idea, just on a massive industrial scale. The tool applies heat from inside the bolt, making it expand just the tiniest perfect amount. And check out how simple this makes the whole process. First, the operator just slides the heater right into a hole running through the center of the bolt. Then, the heater applies this super fast, super focused heat. The bolt expands to a very specific, calculated length. And just like that, the nut can be loosened or tightened with almost no effort. It's so elegant and it just works. But here's the thing about great engineering. It doesn't just offer one solution and call it a day. It adapts. Because not all machines are built the same, right? Sometimes you've got plenty of room to work, but other times you're trying to get into a really cramped, awkward space. And that's exactly why there isn't just one version of this bolt heater. Nope, there are two different models. So this gives us two specialized tools for the job. First up, you've got the straight model. It's rigid, it's simple, and it's perfect for those standardized setups where access is no problem. But then you have the flexible model. This one has a heating element you can actually bend, which is an absolute game changer when you're dealing with complex machinery and tight, weirdly shaped spaces. It really drives home a key point. You design the tool to fit the job, not force the job to fit the tool. And this idea of making the tool fit the job, it goes even deeper. We're moving beyond just having a straight or a flexible model. This entire technology is actually built around the idea of total customization. It's all about engineering a solution for the exact needs of any machine out there. And you can see this mission spelled out so clearly in their philosophy. This isn't about selling some one-size-fits-all gadget. It's about working hand in hand with clients to build a tool that is perfectly, precisely engineered for what they need. The whole point is to make sure they can hit their operational goals safely and with absolute precision. And believe me, when they say custom, they are not kidding. A client can specify everything. We're talking electrical specs like power capacity and voltage, all the way down to the physical size, the diameter, the overall length. You can even define the exact active heating zone. That means you get the perfect amount of heat delivered to the exact right spot every single time. It's amazing, but what might be most impressive is just how simple they've made this incredibly complex process. All the client has to do is download a simple template, punch in their unique specs, save it, and email it back to the expert team. That's it. It's a really smart, streamlined system for ordering a super sophisticated, custom-built tool. So as we start to wrap this up, it's pretty clear that this story is about way more than just a clever bolt heater, right? It's really a perfect example of a much bigger theme you see all the time in great engineering and innovation. So let's do a quick recap of what we learned. We saw that a massive industrial problem, that giant bolt, can be solved not with more muscle, but with smarter, focused tools. We learned that induction heating is a much safer, much more precise way to go. We saw how thinking ahead creates flexible solutions for very specific situations. And maybe most importantly, we got a great reminder that some of the most crucial innovations are the ones we never even see, the ones quietly making our world tick. And that really leaves me with one final thought for you. The next time you see some massive piece of infrastructure or a really complex machine, just take a second and think about the hundreds of little, simple problems that had to be solved to make that thing possible. What other simple-looking problems are being solved right now by some brilliant, unseen engineering? It's a pretty fascinating world out there hiding in plain sight.